Welcome to another lovely video class. Actually, it's probably the first one. A couple of notes here. Make sure while you're doing this, you aren't doing like a normal YouTube video. You're pausing it, taking notes, looking at what I'm doing, trying to understand each of my steps, rewinding if you need to rewatch an example. Take your time. Don't just sit there and zone out and watch it. A little warm up for you. You can pause it, do a couple, see what you can find. Feel free to send me any that you find that I don't have here. Pretty straightforward one. I'm not going to find all of them right now, but 9. Okay, what is happening? 9 plus 7 is 16, plus 5 is 21, plus 3 is 24. It's going to be hard to answer homework questions on a video, but don't be afraid to ask for help on formative, be reaching out, put anything in there that you need. So imaginary numbers, which you'd think, what? Those aren't real, but here we are. So if you think about square root of 9, that would be 3 times 3, or it could be negative 3 times negative 3. Both of those would equal 9. And square root just means what number times itself equals this number. But then if I ask you to find the square root of negative 9, well, you might say, well, do negative 3 times negative 3, but we already did that. We know it equals 9. Okay, that doesn't work. Well, then what about negative 3 times 3? Well, those aren't the same numbers. Those are different numbers. So square root of negative 9 with our number system isn't possible. But there are reasons that we need to be able to do this. It's actually used a lot in electrical engineering and video games. There's other uses for it too. So what we do here is we then will change this to square root of negative 1 times the square root of 9, because this is the real issue. The negative is what's messing everything up, because this would be the same as square root of negative 1 times 3, because we can do that square root of 9. It's that square root of negative 1 that's a problem. So here's some vocab for you. Imaginary number is defined as the square root of negative 1, what we were just talking about. We will refer to this as a lowercase I. With this font, it's not great, but usually that's a J, isn't it? Oh, come on, stop. Like that. By definition, I squared equals negative 1. Might take a moment to pause the video and think about why would I squared equal negative 1. So I squared would be the same as the square root of negative 1 squared, which would be square root of negative 1 times the square root of negative 1, which would just get you negative 1. In electrical engineering, capital I is something that comes up a lot, represents current, so sometimes you'll see it as a lowercase j. A complex number is just a combination of a normal number or a real number mixed with an imaginary number. So 3i would be an imaginary number. Even though 3 is a number that we've dealt with, 3i is now imaginary because of that I. So this would be an example of complex number, this one as well. And then notice that you treat i's just like you do a radical or variable. So some examples to run through. 3i plus 5i is just 8i. That's like the same as 3 square root of negative 1 plus 5 square root of negative 1, which we worked on that a couple weeks ago, adding and subtracting radicals. You just add the coefficients together. For the second one, 7i minus 4i would be 3i. This third one, if we had 7i plus 5i, that's like our first example, that would just equal 12i. But if you take away that I and the 5, you can't add those together now. They represent two different things, so that would just stay as 7i plus 5. You can't add those together because they both don't have the same I. And remember, I is different than x. X represent, or any other variable. A variable represents the opportunity to have different numbers there. We're trying to find what number would we plug in for x. Here, I is specifically equal to square root of -1. So I does represent a number and the same number every single time, whereas like if we had 7x plus 5, this x right now could be any number, including I. For 4, multiplying these together, we'd get 4 times 3 times I times I. So that would be 12 times I squared. We already talked about I squared. That would be 12 times -1, which is -12. Square root of -121. I'm going to separate those out into our two different values there. So square root of -1, we know is I. Square root of 121 is 11. So that would be 11I. Here we'd have square root of -1 times square root of 64 plus the square root of -1 times square root of 49. And that would get you 8I plus 7I, which equals 15I. So when you have these multiple i's in a row, just work on pairs of 2, because we know I times I is I squared, which is -1. So this would be -1 and -1, and -1 times -1 is +1. For this one, we can multiply what's like. So 2 times 8 is 16. And we'd have square root of 9. But we already know we can't do square root of -3 and square root of -3, right? So the key here for something like this is before you multiply those negatives together, you need to pull out the i's. So 2 times 8 is 16. Then we'd have square root of -1 times square root of 3 times the square root of -1 times the square root of 3. That'd be 16. Square root of -1 times square root of -1 is -1 times 3, which would be -48. If we hadn't have done that, if we would have kept going down our path, we'd have 16 square root 9, which would be 16 times 3, which would be 48, which is what we don't want, because that would be different than our actual answer. So our actual answer is -48. All right, try these problems, pause the video, and then I'll go through them. First one, square root of -1 times square root of 36 would be 6I. This one could be a little tricky. So remember, I'm going to break this up into all of our perfect squares. So we've got square root of -1 times square root, well, 27 is not a perfect square, times x squared times x squared times x. This would be our x to the 5th. So I just rewrote that as x squared times x squared times x. So then we would have square root of 27 would be 9 times 3. Square root of 9 is 3. So we would have 3x squared. The 3 comes from here. Square root of 9 is 3. The x squared comes from this would be an x. This would be an x. And then we've got I, so 3x squared I, and then square root of 3x, because we have left over this 3 and this x. Next, we have square root of -1 times square root of 16 plus square root -1 times square root of 25. So that would be 4I plus 5I equals 9I. Then I to the 6th, well, actually, let's do I squared would be -1, a negative 1 to the third. Negative 1 times negative 1 is positive 1. Multiply that by the other negative 1, and you get negative 1. All right, last set of examples or practice problems. Go ahead and do these. So this first one here, this would be 3 times square root of negative 1 times the square root of 27 minus 4 square root of negative 1 square root of 8. Square root of 27 is going to simplify to 3 root 3. Square root of 8 is going to simplify to 2 root 2. So we would have 3 times 3, which is 9, I square root 3 minus 4 times 2, which is 8, I square root 2. And those can't be added together because those square roots are different. We'd have negative 1 square root of 11 times square root of negative 1 square root of 11. So this times this would become negative 1. This times this would become 11. So we get negative 11. 2, 2, 2, 2. That's negative 1, negative 1, negative 1, negative 1. Positive, positive. So we got positive 1. And then we'd have negative 40 I squared. But like we've talked about, I squared is just negative 1. So we got positive 40. There are lists of assignments for the week. Again, make sure you ask for help on formative. Reach out if you're having trouble, and then I'll see y'all on Wednesday.